Yeah, my brother had been messing about trying to make a foam cutter. So this is foam cutter Mark II, copy of my brother's. First piece of board with a slot. Simple piece of board with a slot. Next stage, piece of board just cut with a round. The idea being that it will go in the slot like that. It will go up and down and it will tilt any angle you want. Well, unlike me, some of you will have a jigsaw. So rather than a hammer and chisel that I used, jigsaw piece of wood and cut that out of it. So basically you've ended up with that. And that's what your cutting wire will be suspended across. Right, so now we add the board. Underneath the board I pinned a piece of steel. If you can see that, it's just a plate screwed on there. Now the slot's down the side. Now the idea being, our other piece here will run down, rest against it and hold. I hope my photography's better. And it'll rock, and you can imagine the wires across the two. You can alter it to any height or any angle you want. So now basically we have a piece of board with two pins that come up through off of a piece of angle bar that's holding it. And pop lock, I found out 2 pegs is plenty good enough to hold it. By the time the hot wire is stringed across there and you're pushing the foam that way through, that won't move. And you can set it any height you want, any angle you want. Now we need to be able to stop to run the material through on. Okay, so now we have a board with a slot cut in it and a big U piece of wood coming up through the bottom and a piece of angle iron to hold the piece of wood steady and 2 pegs to hold it. The string will be across from here to here, and now there's a another bit of wood. I am a retired engineer. There's a piece of wood now for a stop to push it through. Now assuming that bit of wood is your foam, your wire will run across here, and you turn your power on and you'll just push that up your stop and straight through the wire and cut your foam. Right, I mean U is in place and pegged against the stop in there, and it's back behind the main cutter, so as when the foam comes through the wire up across here. Now I've just made a little thing like that the wire will run over, it'll run over there and down here, and the end of it will be tied to an elastic band that will be suspending it down to a pin down here. So the wire now is going to be, you wrap your new piece of wire round that little hook there. It's on macro, so it's hard for me to do. You run it across and you rest it over this one. You don't tie it, you rest it over it, and down in that there's another little V there, and then there it'll be tied to an elastic band and down. Now your one power supply, your inlet will be going onto there, and your outlet power supply will be soldered onto the other side. So when the power goes in there, it won't affect the elastic band at all, because it won't be hot that end down, it will only be hot from there over. Right, just a note before I go soldering, the wire I'm using, I don't know if you can see it, it's very thin, it's like fuse wire. I'm not sure what size it is, but it's called resistance wire. It's, don't know, somehow it puts resistance up for the power. And I'm lucky because I got it out of an old sewing machine treadle pedal. You can see it, there's a big load of it wrapped around the thing there. So I've got enough there to last me for a lifetime, I think. I'm winding it off of there, I only want 10 inches at a time. But when you join 10 inches of this straight across the 12-volt battery, believe it or not, it doesn't blow, it glows just right. And the power supply I'm going to use, you'd never believe it. I don't know if you can read that on macro, but it's a normal plug. It's 12 volt, 1 amp. And the actual end of it, you can see I've still got my test wire joined to it. The other end just plugged to the inside. And there's the piece of wire there, 10 inches long, and it glows perfect. So that's all you need for a power supply. So nothing, no fancy electronics, No dangerous 240 volts. 100% safe. Okay, so while I'm on macro, we've now took our U board, that's this one, and we've put the two wires, or the wire from that, down onto here. We've run one up there to that terminal, which is a fixed terminal, and the wire, if you can see it, is wound round it. Then the other wire has gone up to here, it's up to it, that's the fixed terminal, soldered there, and the wire's wrapped round there. See the wire wrapped around there, and then the other side, as I say, power comes up to there, and it rests over the top. The wire, the live is actually joined on to that fitting on the top, but the wire, the thin wire, comes over down here and is just looped around the elastic band, and the elastic band goes down onto the nail, which holds the wire, I don't know if you can see it, tight. Now I'll put it in place and show you it working. Okay, so now I brought me power lead over and plugged my adapter in, and the wire now is running down and round. It's smoking, but I just cut a little bit of foam down and round until the 2 points I told you. This one here though, that one there, sorry, is just, that one here is just over the top and pulled down on the elastic, so it keeps the tension. If you put wire in that's got any bows in it, when the wire heats up, it all comes out. Now to show you how quick it cuts, this is just straight off of a little adapter. It's not overstressing the adapter because it's got a resistance wire. You just put that in and push it through. I think the cut too. Sorry there, the battery went. I'll do that again. I've now plugged my mains lead into my adapter plug. All my things are pegged in place. The wires across, as you can see, and the tools had a couple of minutes to warm up. So now this is just a piece of old foam that come with my RC transmitter. So here it goes. Quite quick there, go straight through. I'm not going to go all the way through, as I say, but there you go. There's the cut, and there is the cut. Not bad, a bit of a jerk there where I went through, but I'm doing it with one hand with the camera. But as you see, if you just drop the foam, perfect. Place the foam. Obviously I'm just messing about, but oh, it went under it, never cut, sorry. Do it again. Pull it through. As you can see, it just cuts on its own. That bit there is just throwing off the wire. That bit there is just a bit of crap. So you see, I'll just drop this piece of foam on the wire and pull it apart. This little foam cutter cost me about £5, I suppose. Just over 2 hours work and £5 to make. Now I can start making models left, right and centre. And it cuts pretty quick. As you see, that's ½ inch, and go for ½ inch that quick. Well, that's all it is. Basically, just a wire straight through to a thin wire, and it cuts. £5 to make, and 2 hours work. How can you want for that? Obviously, if you're doing any long bits, you'll need to make something up to go on the end, so as your foam comes through your cutter, you'll have something on the end here to support it if it's a long thin wing. But that's all for me to do in the future. Basically, I'm letting you know you can make a simple foam cutter with the right wire and a normal 12 volt charger. Before I sign out, I will apologise for the photography work, but it is our work filming. and trying to show things at the same time. Over and out.